So parametric equations, we're back to those, but we're going to differentiate them today. So hit pause, copy the lesson objectives down. When you're ready, hit play again. Okay, so when we last looked at parametric equations, we found that we could define x and y in terms of a third parameter or variable t. So what we're going to look at today is how we can differentiate x and y in terms of t without having to revert to Cartesian coordinates. What we can say is if x and y are functions of t, then we can define our gradient dy over dx as equal to dy over dt times dt over dx, with the dt's cancelling, or we can write it as, which is more useful for us, dy over dt divided by the inverse, the reciprocal, so dx over dt. So we want to make some notes on that. And once you're done, hit play again and we will look at an example. Okay, so in this example it says find the gradient at the point P where t is 2 on the curve given parametrically by x equals t cubed plus t and y equals t squared plus 1 with t in reals. So let's take our y function. Y is equal to t squared plus 1. We differentiate y with respect to t. We get 2t. And we're given that x is equal to t cubed plus t. So differentiate x with respect to t. We get 3t squared plus 1. Now we know from earlier dy over dx is given by, in terms of t, dy over dt divided by dx over dt. So if we substitute for dy over dt and dx over dt, we have 2t divided by 3t squared plus 1. And we've differentiated it then. Now we want to find the gradient at the point t equals 2, so we sub in for t. So let's at t equals 2, dy over dx is equal to 2 times 2 all over 3 times 2 squared plus 1. And so that gives us 4 over 12 plus 1, or 4 over 13. So that's our gradient at t equals 2. So I think you want to hit pause, copy the example down, and when you're done hit play and we'll look at another example. So in this example you want to find the equation of the normal at the point P where theta equals pi by 6 to the curve with parametric equations x equals 3 sine theta and y equals 5 cos theta. Okay, so let's do that. We've got y is equal to 5 cos theta and x is equal to 3 sine theta. Well, first we want to find the gradient at this point. Okay, so if we differentiate, our third parameter this time is theta, so we differentiate with respect to theta. So dy over d theta is equal to minus 5 sine theta, and dx over d theta is equal to 3 cos theta. So our formula tells us that dy over dx is equal to dy by d theta divided by dx by d theta. So we can sub then for dy d theta and dx d theta. It gives us minus 5 sine theta divided by 3 cos theta. And so that's our gradient of the curve. We want the gradient at this point theta equals pi by 6. so we sub that in at theta equals pi by 6. The gradient dy by dx is equal to minus 5 sine, oops, not sine theta, sine pi by 6 divided by 3 cos pi by 6. Okay, so you can put that in your calculator, and that's going to give you the gradient at this point as equal to minus 5 over 3 root 3. And if you can confirm that for me. So that's the gradient at that point there. The gradient of the normal is perpendicular. So that's going to be the reciprocal of this times minus 1. So that's going to be equal to 3 root 3 over 5. Okay, so we found the gradient, and we found the gradient of the normal. So what we need to do now is find the coordinates of x and y at this point. So let's do that. We just get a bit more room on this page. Oops. So if we just make a little bit more room, there we go. If you need to rewind and pause, do that. Right, so we need the coordinates at this point. So it's saying now find the coordinates of x and y. Of x and y, where theta equals pi by 6. Now we got y is equal to 5 cos theta, and x is equal to, what was it, 3 sine theta. So now we sub in for theta pi by 6, so that implies that y is going to be equal to 5 cos of pi by 6, and x equals 3 sine pi by 6, which I'm sure you can do without a calculator. You get 5 root 3 over 2 for y, and for x you should get 3 over 2, which is a simpler function. So you can hit pause and copy that down. I just need to make a bit more room to find the equation of the normal now. Tell you what, if I just put my coordinates as as 3 over 2, 5 root 3 over 2. And you can hit pause and copy, and I'm just going to make a bit more room on the page. There, that'll do. Right then, so the equation of a normal, can we remember from the first year? Normal is given by, so you should have y minus y1, which is equal to the gradient m times x minus x1. We've got all of these parts, so we sub them in. Y minus y1, 5 root 3 over 2, is equal to the gradient, which is 3 root 3 over 5, x minus x1, which is 3 over 2. Okay, so let's expand the brackets and simplify. So go y minus 5 root 3 over 2 is equal to, if we multiply that, we get 3x root 3 over 5 minus, so it'd be 9 root 3 over 10. So y is equal to 3x root 3 over 5 minus 9 root 3 over 10 plus 5 root 3 over 2. The 5 has changed sign coming over this side. So that's equal to, if we put everything over 10, make it a lot easier. So this one's going to be multiplied by 2. Gives us 6x root 3 over 5 minus, that's already over 10, plus, got to multiply top and bottom, numerator and denominator by 5, so you get 25 root 3 over 10. Ooh, why have I left that over 5? That should be over 10. I'll just change that quickly. And I tell you what, at the same time, I'll just grab a bit more room. Here's my pen. I think that's the wrong one. That one. Right. So that should have been over 10 because we've multiplied it by 2. Everything's over 10. So y is equal to 6x root 3 over 10 plus 25 minus 9. 25 minus 9 gives us 16 root 3 over 10. If we multiply through by 10, then we get 10y is equal to 6x root 3 plus 16 root 3. And I can see that 2 goes into everything. This is 16 there. So if we divide by 2, we get 5y is equal to 3x root 3 plus 8 root 3. And we can leave it in that form. That's fine. If you want it to equal 0, you could also make it 5y minus 3x root 3 minus 8 root 3 is equal to 0. Either form is fine. Okay. So I think you want to hit pause, write the example down, and once you've done that, I've got some questions for you. Okay. I know this is something that people forget, find the equation of the normal or find the equation of the tangent, but it is pretty straightforward. You do have to practice. Right, some questions for you. Okay then, so exercise 9G, probably useful to practice most of question 1 before you move on to the remaining questions. Right, I'll attach the questions to the assignment. Okay.